How are you all? Students, today we are going to start with the new topic of approximations, and we will going to see how we are going to find the approximate values of different numbers using differentiation. Students, very first question of exercise 6.4 is using differentials find the approximate value of each of the following up to 3 place of decimal. So very first part is under root 25.3. So let us see how to calculate the approximate value of root 25.3 using differentials. The first part is to find the value of under root 25.3. So student, listen this carefully. We will take that whole value as x whose root is possible. So as you can see, 25.3, 25 is an exact root, 25 root is 5. So here we will take that value as x whose exact root is possible. If it is cube root, whose cube root is possible. If it is fifth root, whose fifth root is possible. Likewise we will take. And whatever the error, so error or you can say change. So whatever the change is there, 0.3 is the change, that will be denoted by del x, delta x. So here we are considering y as a under root x function where x is equal to 25, that is the exact value whose root is possible, and delta x will be the change in that. Suppose students it is 24.1 or say 24.9. Then we will take again x as 25 and our delta x will become minus 0.1 because 24.9 is away from 25 by minus 0.1. So likewise we will consider x and delta x. The next procedure is same as we used to do in the first principle differentiation process in class 11th. So here we will find delta y. So change in y will be the whole function of x, that is under root x plus delta x minus root x. So we will substitute these values. The value will be under root 25.3 minus root 25, and root 25 is 5. What we need to find? We need to find the value of root 25.3. So we will keep at one place and rest we will transfer on the other. Now our next step is to find the value of delta y and substitute here. Students, remember that delta y or dy are approximately the same values. So delta y is given by dy by dx into delta x. Now comes we will find dy by dx. How we are going to find dy by dx? By actually differentiating y with respect to x. And we know that the differentiation of root x is 1 by 2 root x. So substitute that. So 1 upon 2 root x into delta x is 0.3, that we have already taken. Just substitute all the values and calculate. So after calculating this, we are getting the value as 0.03. So that means the approximate value of under root 25.3 is 5 plus 0.03, that is 5.03. Students, do remember one thing also, that the value of root 25.3 must be very much near to 5, as root 25 is 5. So that means root of 25.3 must be very much nearer to 5. Students, part 2 of question number 1 is very much similar to the part 1 of this question. So do try this question. So we are starting with next third part, that is under root of 0.6. Now the value which is exact having the root near to 0.6 is 1. So here we are going to consider x as 1. Y is again an under root function of x and delta x will be the change. So change for 0.6 by taking x as 1 is minus 0.4. So that means delta x will be minus of 0.4. Next is the same procedure. Delta y will be equal to whole under root of x plus delta x minus root x. Next we will substitute the values. On substituting the values, we will get under root 0.6 as 1 plus delta y. Next step is to find the value of delta y, that is dy only. So dy will be equal to dy by dx into delta x. Again the root differentiation is 1 upon 2 root x into delta x. We will substitute the value of root x and delta x. So after simplification we are getting it as minus 0.2. So that means under root of 0.6 is equal to 1 plus minus of 0.2. So which come out to be 0.8. So that means under root of 0.6 is 0.8. I hope students you have understood this well, and do practice these three parts again at home. That's all for today, students. Do revise what we have done in the class today and do your homework also. Thank you so much, students. Take care and have a great day ahead.